Morning students, welcome to this video. Today we will do gamma and beta function. This chapter is very important in BTech first year and also those who are doing bachelor in mathematics. So gamma and beta function, first we will start with gamma function. The gamma function main formula is gamma n equal to integration 0 to infinity e to the power minus x to the power n minus 1 dx. This is the main basic formula. This formula is very much important because we will use this formula for doing sums. Of course, this gamma function also have some properties, but before listening the properties, we have to know that this n is always greater than 0. You have to remember this for doing sums, and these things also come in MCQ, right? So now let us know the properties. Okay, before starting the properties, first let you know how to use this formula, right? See, if n equal to half, that is, if gamma is half, then how we will write this? First we will write integration 0 to infinity e to the power minus x, right? X to the power half minus 1, right? And dx. This is the correct one. So we can write this integration 0 to infinity e to the power minus x 1 by x to the power half dx, right? Now let's take another example for making easy. Now let's take if n equal to 3 by 2, that is gamma 3 by 2 integration 0 to infinity e to the power minus x to the power 3 by 2 minus 1 dx, right? Suppose if n equal to 5 given, that is gamma 5 equal to integration 0 to infinity, then e to the power minus x to the power 5 minus 1 dx, right? So integration 0 to infinity e to the power minus x to the power 4 dx. So hope you have understood how to use this formula now. Now let's talk about properties of this function, which is very important for doing the sums. Okay, so properties of gamma function. Okay, number 1 properties is gamma 1 equal to 1. Okay, suppose let's take an example here. Gamma 1 equal to integration 0 to infinity e to the power minus x to the power 1 minus 1 dx, right? So integration 0 to infinity e to the power minus x not dx, right? Since this is an improper integral, as you know that gamma and beta function is an improper integral, so here there is infinity, so we will take limit a to infinity integration 0 to a. Okay, we can write here a because we have taken the infinity in a using limit. So e to the power minus x dx, x naught means 1, so we can write this. Okay, fine. Then again limit a to infinity integration e to the power minus x is always, suppose you are doing e to the power minus x, right? Integration e to the power minus x dx, integration e to the power minus x, we is here, as here it is minus 1 into x is there, integration e to the power x, we get the answer ex plus c, right? Here it is integration e to the power minus x, so here then the constant minus 1 we will put it here, that is minus e to the power minus x. That means if e to the power 3x, integration e to the power 3x is present, sometimes if question comes, then the answer will be 3 e to the power x, right? Like that only, integration e to the power minus x, the result comes minus e to the power minus x. Okay, fine. So we will put, as it is a improper integral, so 0 to a, right? So limit a to infinity minus e to the power minus a plus minus minus plus e to naught, right? So we get the result 1. Okay, so I hope you got it. Gamma 1, we got the result 1. So this is the properties, gamma 1 equal to 1. We have to remember this. Property 2, gamma n plus 1, we can write in gamma n, okay, where n of course is a natural number. Okay, let's take an example. Suppose the question given to evaluate gamma 11 by 2. Okay, gamma 11 by 2 we can write as gamma 9 by 2 plus 1, right? So we can write here 9 by 2, gamma 9 by 2. Okay, I hope this is clear to you. Again we can make it in simple version, that is 9 by 2 gamma 7 by 2 plus 1, right? So 9 by 2 into 7 by 2, gamma 7 by 2. Fine, let's complete the sum first. Equal to, gamma here came 9 by 2 into 7 by 2. So let's put it 9 by 2 into 7 by 2 into 5 by 2 okay, 9 by 2 into 7 by 2, gamma 5 by 2 plus 1. So again we can write this 9 by 2 into 7 by 2 into 5 by 2 into gamma 5 by 2, 9 by 2 into 7 by 2 into 5 by 2, 3 by 2 plus 1, right? Then again 9 by 2 into 7 by 2, 5 by 2 into 3 by 2, again, okay, 9 by 2 into 7 by 2, 5 by 2 into 3 by 2, half plus 1, and 9 by 2 into 7 by 2, 5 by 2 into 3 by 2, half, gamma half. Now you have to note down this, that gamma 9 by 2 into 7 by 2 into 5 by 2 to 3 by 2 into half. This gamma half we can write as root over pi. Okay, gamma half is equal to root over pi. Okay, so the answer will come 945 by 2 to the 4 to 4 32 4 to the 8. Okay, so this is the answer. Hope it was clear. Now let's do the next property, number 3. Number 3 property is that gamma n plus 1 we can also write as n factorial. Example such as gamma 4 equal to gamma 3 plus 1 equal to 3 factorial, and 3 factorial means 3 into 2 into 1 equal to 6. So this is the number 3 properties. Property 4 is that gamma half, I have told you, equal to root over pi. So these are the most important 4 properties which you should remember. These are the really 1 2 3 4 very important properties which you should remember for using this formula for gamma function. So hope you have got it about the gamma function. Now let's start the beta function. Okay, so this is the beta function formula, main formula. The improper integral is improper integral is a function of m and n denoted by beta mn, integral 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. In this case, m and n is greater than 0. Okay, you must remember this. So let's tell me how to use this formula. Suppose if m equal to half, also n equal to half, that is beta half comma half, right? We can write as integral 0 to 1 x to the power half minus 1, right? 1 minus x, here is n minus 1 dx, so half minus 1 dx. We can now let us do the simplest form of this. So 0 to 1 we can write x to the power minus half, 1 minus x minus half dx. So this is the simplest form. Now let's talk about properties of beta function. Properties of beta function. Property number 1. Property number 1 tells us that beta m comma n equal to beta n comma n is always equal. Okay. Property number 2. Property number 2 tells us that if m is a positive integer, then beta m comma n equal to m minus 1 factorial by n plus 1 n plus 2 to n plus m minus 1. This is property number 2. Property number 3 tells us beta m comma n equal to 2 integration 0 to pi by 2 sine theta sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. This is a very important formula. Okay, suppose let's take an example for this property. Suppose evaluate integration 0 to pi by 2 sine to the power 5 theta d theta. How we can write this formula to this? Let's see. Okay, we can write half into 2, as we have to make this formula form half into 2 integration 0 to pi by 2. Okay, sine we can write 5 2 into 3 minus 1 theta, right? 3 to just 6, 6 minus 5. Okay, so sine 2 into 3 minus 1 theta. As there is no cos value, so cos to the power 0 means 1, right? So we can write cos as cos 2 into half minus 1, right? 2 will get deleted, and theta. Okay, so d theta. So this form we can write. So we get the value m equal to 3 and n equal to half, right? So beta 3 comma half, right? That beta m comma n equal to integration 0 to infinity x to the power m minus 1 plus x m plus 1 dx. Hope you have understood the formula. Now property 5, beta half comma half we can write as pi. Okay, property 6, there is a relation between beta and gamma. Relation between beta and gamma. The formula is beta m comma n gamma m by gamma m plus n. Now from this beta 3 comma half we can write as gamma 3 gamma half gamma 3 plus half, right? Gamma 3 we can write 2 factorial. We have learned in the properties of gamma, right? Gamma half we know what, root over pi. So gamma 3 plus half is 5 by 2, right? So gamma 5 by 2, 2 factorial equal to root over pi. 2 factorial into root over pi, 3 by 2 into gamma 3 by 2 plus 1, we can write this, right? 2 factorial into root over pi, 3 by 2 into gamma half plus 1. From this we can write 2 factorial into root over pi, 3 by 2 into half gamma half, right? So 2 factorial into root over pi, 3 by 2 into half gamma half we can write as root over pi. So root over pi, we can cut it down, and 2 factorial means 2. So 3 by 4 equal to 2 into 4 by 3, right? So 8 by 3 is the answer. Okay, so hope you have got it. This is the complete properties of beta and gamma. These are very important. Continue to practice from your exercise of your book which you have got from your college. So thank you. We will meet in the next video. Till then, keep learning.